So we're going to study the shape of graphs a little bit more with concavity. So big class. Okay. Okay. Concave up and concave down. Okay, if I have a graph that's concave up, what's happening to the derivative? Not necessarily.
Wait, not necessarily to.
Brandon. Okay, let me do these in a different color. Think about the slopes of the tangent lines. What's happening to those? This would be negative, right? Yeah. Okay, what about this one? What's happening to this one? Okay, what do we call that in math when it's negative, 0, positive?
Increasing?
Yep. Thank you, Trevor. So if it's a concave up graph, the derivative is increasing. Okay. Because we're going from negatives to positives. So we're going up, right? So we can do the same thing with concave down. What's happening to f prime? Yeah, it's decreasing. Yeah, the slope of the tangent lines are decreasing. So you got a positive, then a 0, then a negative. Okay. Here we had a negative, 0, positive. So that's thinking of concavity in terms of the first derivative. Okay. So sometimes you're given a graph of f prime. If it's increasing, you know that it's concave up. If I give you something of that nature, there's a point where we transition from concave down to up, right? That's that one thing? That, no, I'm just kidding. Okay, point of inflection. Yes, we got it. You guys are awesome. Now I'm happy. Yeah, it's called a point of inflection. Yeah, it was in that packet. You're correct. Okay. How do we find the location of points of inflection? That's the question of the day.
You find the inverse of the derivative.
No, it's really not that difficult. You set the second derivative equal to 0.
Oh, I think.
See, because you can look at, right, and you have to have a sign change. That's required. Okay, the critical points did not have to have a sign change to be a critical point. Okay, anything with the slope equal to 0 or undefined was a critical point. At a point of inflection, you have to have that 0 second derivative, but it has to have a sign change. So the second derivative here would be negative, and this would be positive, right? So the second derivative is shows this concave down. Second derivative shows that concave up, okay? So the second derivative can also show us concavity. So here, concave down, it's less than 0, negative. Okay. Concave up, it's bigger than 0. Okay. That's very similar to our if f prime is positive, what's the functions doing? If the derivative is positive, the function is increasing. If the derivative is negative, it's decreasing, right? The second derivative gives us concavity information now. Okay, so that, let's see. Let's find the points of inflection of cosine x.
Why is that throwing like natural log and cosine?
Because that's how we roll. Just be thankful we restricted this one to one period of cosine. Because then there would be an infinite amount of answers and you would never finish your calculus homework. Bummer.
Darn.
Darn. I would love to do calculus for the rest of eternity. I'm pretty sure I wouldn't even want to do that. Okay, so if we want points of inflection, we need to find the second derivative, right? So what's the first derivative?
Negative sign.
And the second derivative? Negative cosine. Okay. And then set the second derivative equal to 0. Where does that happen? Pi over 2 and 3 to pi over 2. Yep. That's a unit circle. Okay. Now, these are the possible points of inflection. Okay, you got to star that. They're possible points of inflection. Okay. We have to do a sign analysis to make sure that they actually are. So, and it's the same deal as before, except we're just going to use the second derivative now. Okay. So, okay, let's pick pi and 0 and 2 pi. The easy one. So these are our points of inflection. What is now f double prime at 0? What's the negative cosine at 0? Pi. This would be negative, but we have a negative there too, so it has to be positive. So, and then 2 pi be negative, right? Yep, so we do have points of inflection here and here. Now they are official, right? And then concave up or down? Concave. Negative. Second derivative is negative. Concave down. Concave up. Concave down. And that is for cosine x. Okay. And if I draw the graph, you can see it, right? 0 to 2 pi. Concave down, concave up, concave down. Okay, and then your points of inflection. So that's what we're looking at. Second derivative, it gives us points of inflection. Concavity. Okay. Would you like to see a polynomial? I mean, they're pretty straightforward. The nice thing about second derivatives and polynomials is they usually give you squareds and x's, but this one doesn't. Awesome. Do you want me to show it to you? Okay. Sure. Let's have 3x to the 5th minus 5x to the 4th plus 1. Find the points of inflection and the concavity. The intervals of concavity. What's the derivative, Mr. Lewis?
First or second?
Mr. Lewis?
Sorry.
Gosh, you're so excited to do calculus. I love it. All right, let's hear it, Mikey. I should write what you say this time. Okay, and Gunnar, what's the second derivative?
60x to the 3rd minus 60x to the 2nd.
Okay, good. I hope you agree, because I think it's right. All right, next step, Alex. You have a comment, Mr. Cornelius?
I was wondering what, like, our... It's scary. You got what it was. Never mind.
Okay, moving on. Alex, what's the next step for finding a point of inflection?
60x squared out.
Okay, we can start there. What's over here? Thank you for listening to your friends.
Thank you, friends.
Well, thank you for listening to them.
Consider you friends.
What are my x values?
X
0 and 1, right? 0 times anything is 0. If you ever have a solo term out front with an x in it, it's going to have a 0 for sure. Okay. And now we can do our sign analysis, right? 0 and 1. For some reason I like to mark my possible points of infection. I've been infected by calculus. Okay. So second derivative at -1. Positive or negative? That's a positive, that's a negative. Right? At 1/2, how am I doing that? Okay, what's -1 squared? 1, that's positive. -1 minus 1 is negative. Negative times a positive is a negative. I don't even need the numbers. Okay, how about 1/2? Oop. And 2. Okay.
So does that mean 0 is not a point?
Not a point of inflection. Yep. What in the... My pen is possessed.
about replacing batteries.
Okay. Here, what's happening?
Right there is a critical point, but it's not.
Concave down. Concave up. If you're going to write this in interval notation, okay, sometimes you're asked for interval notation, so make sure you can write it in interval notation. Yeah.
If it's going from negative to negative, how is it a concave line?
How's it concave? Second derivative is negative. Concave down. Look at let me see. Okay, Logan, if you look at page 236, there's a graph of the function there. Okay, and it'll show you why that is not a point of inflection. Okay.
Why is it
I
concave down?
understand the concave up, concave down. I don't understand why negative and negative makes concave down.
Because it's doing this.
How? If it's still just like a negative line.
It's not, okay, we're not in the first derivative.
Positive slope to a negative slope.
We're not worried.
No.
Okay, we're not working with the first derivative anymore. You're thinking in terms of first derivative slope, right? So all you're thinking is that, right? You're thinking tangent line down. What you got to think is this is a second derivative now, which tells us negative is concave down. Okay? So we're at the second derivative. If it's negative, that tells me it's concave down. The first derivative, so let's make sure this is, if the first derivative is negative, all I know is that we're decreasing, right? Okay, if the second derivative is negative, that is concave down. That's the difference, okay?
Wouldn't there be two concave downs?
Yeah, and he just showed it to you. It would look like this. Because see how this is concave down and so is this? For some reason, this point is throwing a possible point of inflection. Okay. All right, let's do one more. Oh, let's do a case where the second derivative doesn't exist. Saucy. You betcha. This is awesome. Okay. This is scandalous right here. What other fun words could I think of?
Scandalous?
Yeah.
I don't like that word. Saucy. Saucy?
Okay, so this is going to show you. This is good for you to see. What's the first derivative, Logan Waterman?
And then 4/3. There you go.
No, -3 from the top.
Oh.
2/3. Yeah, so take the denominator, subtract it out. Okay, good. Logan McClung, second derivative. Turn that frown upside down.
My frown is concave down.
I know. It's
Oh,
awesome.
good.
But it just turned concave up because now you're smiling. It's the second, the power rule again. So bring 2/3 down. What do you get when you multiply it?
5 seconds.
5 times 2 and 3 times 3, right? And then what's the new exponent? Subtract 3 from the top. No, subtract 3 from the top.
-1/3.
Yes. Okay. So if I rewrite this, which is my habit,
You're gonna cry.
no, I'm good.
Okay.
Question is what sentence?
What are you talking about?
Yeah, where are you?
Are we confused with fraction math?
No, I thought you said
No, they are. It doesn't exist because there's a square, there's a cube base.
Oh, so that can't happen.
You're not you, Neil, capitalists.
You're not you and your Catholic.
Can this be true?
No.
Never, right?
Not ever. So it's not.
Not possible. Okay, but here's the little twist on things that sometimes happens.
Always.
Okay, where is this undefined?
Everything.
No, zero.
Right?
Yes.
Yes?
Yeah.
You agree? The denominator is 0 at x equals 0, right? What?
That can
It's
never
not,
equal
it's not
zero.
possible.
It can never equal
Yeah.
Right, the top would have to be the 0, right? If I put a 0 on the bottom, it's undefined. Correct?
Yes.
Okay, this is a possible point of inflection. All right? Yeah. No, it's not that big a deal. See, you're looking for where it's undefined or 0. The second derivative is undefined or 0, okay? Now we can do a sign analysis again, right? To test for concavity on each side of this spot. Zero, -1 and 1. Okay, if I plug -1 in, what do I get?
Over. It's gonna be a negative.
What's the cube root of -1? Is it a negative?
Oh.
No. See, that's square root. Cube roots can be negatives, right? So negative. And what if I plug 1 in? It's a positive. Do I have a concavity change? I do. And I so have a point of inflection. No, it's not possible for it to equal 0. If it's undefined at this spot, think of this as a possible. I can, over a vertical tangent, I can still have a concavity. Okay. If it's undefined at 0, this is our possible point of inflection. So do a sign analysis on each side of it. Okay? All right. Are you okay if I'm done? Tomorrow we talk about this a little further. Okay, let me write your homework down.
I'm sorry.
Anger does not solve many problems. I said it doesn't solve many problems.
Anger
Leads to suffering. Yes, thank you for that, Mikey. Okay, 4.4. My mouse writing skills are not proficient at this point. Did we check free response 1 from AP2 earlier?
I mean, we don't have to.
Are you serious? You guys pulled that on me?
Yes.
I'm so going to give you all a 0.
I really
Do you have the answer?
In my mind.
In my mind's eye. Yeah, right.
I don't.
Okay, there you go. And just for good measure, do it again. No, there will be no killing of ourselves.
Well, that's the weak way.
Oh.
Are we still on video?
Yeah, we still have video.
Someone's
Someone's gonna watch the video.